Okay, so we're gonna try to recall a couple things here first. So with your simplifying square roots, so 5 times, square root of 5 times the square root of 10, square root of 50. 50 is 5 times, or 25 times 2, so 25 times 2, the square root of 25 is 5. I still have the square root of 2 there. 243. 243, so the biggest perfect square that goes into 243. So 243 divided by 81. So 81 is 9 times 9. That works actually. So 243 is 81 times 3. The square root of 81 is 9. I have 9 square roots of 3. All right, remember this is the same thing as the square root of 4 over the square root of 3. I can simplify the radical, square root of 3 over square root of 3. So I multiply the top. I have the square root of 12 over 3. But again, 12 came from 4 times 3. The square root of 4 is 2, so I have 2 square roots of 3 over 3. Okay? All right. Another thing you want to recall here. So some formulas we want to recall. So we have the distance formula. So we have x2 minus x1 squared plus y2 minus y1 squared. So you can use this to show congruent sides or to find lengths. Your midpoint formula. So x1 plus x2 over 2, comma, y1 plus y2 over 2. Again, we'd use this if we want to find the midpoint. Slope formula. It's your change in y over the change in x. You could use this to show the lines are parallel or show that they're perpendicular. All right, so classifying a triangle. So it says a triangle has vertices at D, 0, 0, at E, 1, 4, and at F, 5, 2. Is the triangle scalene, isosceles, or equilateral? So what I'm going to have to do here, to show any of these are true, I'm going to have to find the lengths and the sides there. So I would use the distance formula. So ED so 1 squared plus 16, that ends up just being the square root of 17. EF, so I'd have 5 minus 1 squared plus 2 minus 4 squared. 5 minus 1 squared is 4, so 4 squared is 16. 2 minus 4 squared is negative 2, but then I need to square it, so negative 2 squared is positive 4, so then I end up with the square root of 20 here. DF is equal to the square root of 0 minus 5 squared plus 0 minus 2 squared. So 0 minus 5 is negative 5. I square that, I get 25. 0 minus 2 is 2. I square that, I get 4. So I get the square root of 29. So none of these sides are equal. So it ends up being a scalene triangle. Okay? All right, this one says classifying a parallelogram. So it's telling me right here that I know it's a parallelogram. Like if I was trying to prove it's a parallelogram, then I would use one of those 6 properties that we've already discussed. Here I already know it's a parallelogram. So the question is it a rectangle? Is it a rhombus? Is it a square? What kind of parallelogram is it? So I want to show, if I can show that the diagonals are the same length, then I would know that it's a rectangle. And then if I can show the diagonals are perpendicular, so the same length for the diagonals gives me a rectangle. Diagonals are perpendicular tells me it's a square, or tells me it's a rhombus, right? So if it's both a rhombus and a rectangle, then it has to be a square. Okay, so if we look at this one, we've got, here's M. N is at -1, -4. P is at 2, 5, and Q is at 3, 2. Oops, I put N in the wrong spot, didn't I? Here we go. And then Q is at 3, 2. Okay. All right, so what I want to do here, so I'm going to find the length of these diagonals, and then I'm going to find the slopes of them to see if they are perpendicular. So I'm going to find the length of MP. So I'm going to do 0 minus 2 squared plus 1 minus 5 squared. So 0 minus 2 gives me negative 2. Squared, I'd get positive 4. 1 minus 5 would give me 4. I square that, I'd get 16. So this is the square root of 20. You could simplify that if you want to 2 square roots of 5. I'm going to do the same thing for NQ. So again, let's say I do 3 minus a negative 1 squared plus 2 minus 4 squared. So this would be 4 squared, so that's 16. This would be negative 2 squared, so that's 4. All right, so the diagonals are the same, so then I know that it's at least a rectangle. Now if I look at the slope of the diagonal, so I'm going to find the slope of NP. So I'm going to do the change in Y over the change in X. So I get 2. I'm going to do the slope of NQ. So I'm going to do the change in Y. And I just wrote the change in X, didn't I? So I'm going to do the change in Y. So 2 minus 4 over the change in X. So this would be negative 2, and this will be 4. So this reduces to negative 1/2. So these are opposite reciprocals. These were the same. So it is a square because diagonals are both same length and perpendicular. So that makes this a square. Okay? All right, this one says classifying a trapezoid, or classifying a quadrilateral. But now if you notice here, it says that I have an isosceles trapezoid. So I have an isosceles trapezoid. So I have point A down here, B is at 2, 4, C is at 6, 4, and D is at 8, 0, which we don't have space for. But so you can see here's the isosceles trapezoid. But then it says, what special quadrilateral is formed by connecting the midpoints of the sides? So some of these midpoints are easy to find. So like the midpoint, I'm going to call, I'll say this one's E, this would be F. So like to find the midpoint of E, so let's say this is E over here. What I'm going to have to do is I'm going to take A and B. So A plus B, so I'd have 2 over 2, comma, and then the y's, so 0 plus 4, so and then I had 4, 2. So the midpoint must be at 1, comma 2. So I didn't draw this very well because I'm not exactly on there, but there's that E right there. Then let's say I use F as the midpoint here. Well, this one's easy enough to find. I mean, you can use the formula if you want, but the midpoint's just going to be at 4, 4. When I find G, I'm going to do the same thing. So with G, it's C and D, so I'd have 6 plus 8, I'll do the math if you want, over 2, and then 4 plus 0 over 2. So I'd have 14 divided by 2, so I'd end up with 7. 4 divided by 2 is 2, so then this is going to be 7, 2. And then this one down here is easy enough, it just ends up being 4, 0. Okay, so then when I connect these, so the question is, what kind of quadrilateral did I make there? So a couple things we could do here. So first of all, let me even show that it is a parallelogram. So to show that it's a parallelogram, I'm going to find the slopes of these sides and make sure that they're parallel. So the slope of EF, so I would have 4 minus 2, and then 4 minus 1, so I have 2 over 3, and I want to compare that to GH. So GH, so I'd have 0 minus 2 over 4 minus 7. So this tells me that EF is parallel to GH. Then I'm going to do the other ones. So EH, I'd have 4 minus 1, no, 0 minus 2 over 4 minus 1. And then the slope of sorry, I just had a thought here. Then I'm going to do the slope of FG. So FG, I'd have 2 minus 4 over 7 minus 4. So negative 2 over 3. So then these slopes again are the same. So I know that EH is parallel to FG. So I know I have a parallelogram. So, I mean, just looking right here, if I'm thinking about the diagonals, this diagonal has a length of 4. This diagonal has a length of 6. So the diagonals aren't congruent, so it's not a rectangle. The question is, could it be a rhombus, since I know it's a parallelogram. So if it's a rhombus, I want to show the diagonals are perpendicular. So if you look right here, the slope of FH, even if you look at this right here, it's a vertical line. But even if you didn't look at that, if you wanted to do the math, so FH, you'd have 0 over 4 and then 4 over 4. So FH would have a slope of, sorry, this would be 4 over 0, so this would be undefined. So it's a vertical line. You wanted to find the slope of EG. So then you could do, so again, you're changing y, 2 minus 2 over 7 minus 1. So you did 0 here. So these are perpendicular. Every horizontal and vertical line are perpendicular. So we know it's a parallelogram because of parallel lines. We know it's a rhombus because it's perpendicular. The diagonals are perpendicular, so it's a rhombus. Okay, I'm not going to do any of the homework problems with you because basically they're just kind of going through this whole stuff again here. What I am going to point out to you though, like a couple things, like if you have a triangle, you're probably going to have to show that the lengths are congruent or the same. If you have a rhombus, if you know it's a parallelogram, then you're good. But if you know it's a parallelogram and you just want to figure out if it's a rhombus or not, you could show that the side lengths are congruent. You could also show that the diagonals are perpendicular. If you have a kite, you might want to show that the adjacent sides are congruent and the opposite sides are not. You also, with a kite, could show that the diagonals are perpendicular. That doesn't answer the whole thing for the kite with diagonals being perpendicular, because obviously a rhombus could also have perpendicular diagonals. A rectangle, you can show the opposite lengths are congruent, show the sides are perpendicular. You could show the diagonals are congruent. You could find the midpoint of each diagonal to show that they're intersect at the same point. You can, for an isosceles trapezoid, show one pair of opposite sides parallel with the slopes, so you're using the slopes, and the other pairs are congruent with the distance formula. So those are just some tips there. It's not everything, but just some things to do when you're trying to figure out how to classify these ones, okay? So that is it for this one.